Okay, so we want to find the inverse of the function. So the first thing we need to do for this one is we need to set f of x equal to y, right? F of x and y are the same thing. They're just the interchange that um, terminology, okay? So, or notation, I should say. So f of x is the same thing as saying y. So y is equal to x plus 3 raised to the third power minus 5. All right. The second thing we need to do is now we need to interchange the x and the y. All right. So we want to interchange the x and the y. So in this case, y will become x and then x will become y. Okay, we swap them. Raised to the third minus 5. And then we solve for y. Okay, so we're going to add 5 on both sides. We get x plus 5 is equal to y, y plus 3 raised to the third power. Then we take the cubic root on both sides. So then the cubic root and the power 3 go away, leaving us with y plus 3, and then we have the cubic root of x plus 5. Okay, then we subtract 3 on both sides, so that cancels. So we get the cubic root of x plus 5 minus 3 equals y. And that's going to be our inverse. Okay, and then that's our answer right there. Okay, so the first thing we need to do is we need to separate. So remember in standard form is f of x is equal to ax squared plus bx plus c, right? That's in standard form. And what we want to do is convert this from standard form to the vertex form first, okay? So in order for us to graph it, all right? So we need to convert this from standard form to vertex form. So our c here is the 31, okay? So our c here is the 31 right here. Okay, so we're going to move that to the right, kind of separate it, and then take these two here and move it to the left of the same side of the equation. I'm not moving it to the other side. So it's still going to be equals 3x squared minus 18x, and then we have 31. Okay, all right. Now remember, we need to use, in order to do this, we need to use completing the square. All right. And in completing the square, the leading term can only be 1. So let's write that down. Note 1. Completing the square. Okay. Leading term has to be 1. Okay. It cannot be bigger than 1. All right. So that's note number 1. Okay. So we have a 3 here. So that means that we need to factor out that 3. So we have 3, and then we have x squared. Factoring out 3 from the 18 will give us a minus 6x, then have some space, and then have 31. Okay, so that's note number 1. Note number 2, now we need to do is we need to do our formula, which is the b over 2 square, right? So in order to complete the square, we need this formula, b over 2 square, okay? All right, so now we have to be careful because the b is not from the original. We want the b from what we factored from, okay? That's what we need to do. That's another point we need to make sure. We're not using the original. We're using what we factored from. Okay, so now that's going to give us minus 6 divided by 2 square, which is negative 3 square, which is equal to 9. Okay? So that means then I'm going to add 9 here, right? Gonna add 9 here. However, that's gonna be my box, right? But here I have to be careful because I can't just, subtract 9, right? Because to balance it, you have to have 0 at the end. So I can't just subtract 9 here because this is being multiplied by a factor of 3. Okay? So that means then I need to multiply or subtract by 3 times 9. Okay? So 3 times 9. Okay, so I put that in my box. Okay? All right, so then now I can simplify. So again, this will be, if I factor this here, that will be x minus 3 times x minus 3. And this one here, 3 times 9 is 27, or in this case, 31 minus 27, which gives us 4. So this will be a plus 4 here. Okay? All right, and then we rewrite this as 3 times x minus 3 squared plus 4. All right, so our vertex form is 3 times x minus 3 squared plus 4. All right, so now if we wanted to graph this, okay, so in this case here, our vertex or h and k is going to be what? The opposite of this, which is 3 and then 4. So 3, 4. So we're going to go right 3 and then up 4. So right 3, 1, 2, 3, and up 4. 1, 2, 3, 4. Right? So that's our vertex. And this is a positive one, right? It's a positive, so this can mean it's a happy parabola. And the 3 here means that we're going to stretch it. Okay, we're going to stretch the parabola here. Okay, again, we just want to sketch. And then that would be, so here's our answer for part A, or the first part of this, right? The vertex form. And then this is our answer for part B, or the second part of this is the graph of that. Okay, so in this case, they want us to determine the quadratic function f whose graph is given. And the vertex is -3, -12, and the y-intercept is -3. Okay, so so basically what we're doing here is we're going to be using the vertex form to set this up. Okay, so let's go ahead and do that. So we have um, f of x is equal to a times x minus h squared plus k. All right, so that's our vertex form. Now we need to write down, what they gave us. So they gave us -3, -12. That's our h and k, right? That's our h and then that's our k. Okay. And then they gave us the y-intercept, right? So this is the y-intercept. So 0, -3 is the y-intercept. So that's going to be our x and y. And our goal here is to solve for A. We want to find A. Then once we find A, then we're going to convert this from the vertex form to standard form. Okay? All right. So let's go ahead and plug in the numbers that we have. Okay? So remember, f of x is the same thing as saying y. So we have -3 for y. A, I don't know. That's what I'm looking for. X is 0. All right? And then we have -3 for h. Now we have to be careful because we already have a minus there. So it's a minus and then another -3. Okay? Square. And then we have k, which is -12. Okay? All right. And then we just simplify. So we have a, this is going to be a +3. So 3 square and then -12. So that's going to be me 9. 3 squared is 9. So they'll give me 9a minus 12. And then y is negative 3. So I bring that down. Okay. Okay, and then we're going to add 12 to both sides. So the 12s go away. We get positive 9 and then 9a. Then do we divide both sides by 9? So a gives us 1. All right. So a gives us 1. So now we take this information and we rewrite it. So we have f of x is equal to a, which is just 1. All right. And then we have, since we move this to the left, it's going to be the opposite. So it'll be x plus 3, right? Because it's going to be the opposite. Plus 3 goes to the left. Okay. Plus here we got a positive 3, right? So plus 3 squared. Okay. And then we have our minus 12. Okay. So this is what we have as our vertex. So this is our vertex form. Okay. All right. So that's what they want. They want the vertex form. We found it. All right. And again, if we were to graph this vertex form, we would get this, right? Move to the left 3 and then down 12. Because you got the plus 3 tells you to go to the left 3, and the minus 12 is you go down 12. Okay. So remember what's in that side of the parentheses, you go the opposite of what it says. Now, if we wanted to write this in standard form, okay, that's okay. We just take our vertex form. It says x plus 3 squared. That means we need to multiply that twice and then subtract 12. Okay, the 1 doesn't matter because it's just going to be multiplied by 1 will be the same thing. All right, so then we just FOIL this out. So we get x squared plus 6x plus 9 minus 12. And then we simplify, we get x squared plus 6x minus 3. All right, so this would be in our standard form. Okay, so here's our vertex form. That's what they want. Okay, and if they asked for the standard form, we just multiply the x plus 3 squared, and then we get this as our standard form. Okay. Okay, it says here the price P and the quantity X sold of a certain product obey the demand equation. Okay, P is equal to negative 16x plus 60. Express the revenue R as a function of X. So it's saying that we want to write our formula or our function in terms of X. And that's actually not too bad. All right, so how do we do that? Well, we're talking about quadratics, okay? So, right, we're talking about supply and demand, or in this case, a demand. So you're going to have or I should say, the revenue. So you have something that's, going to go up in sales. There's a maximum to that sale, right? And then they'll come down, depending on the price that you set at. Okay, so we talked about this. All right. I think particularly the Taylor Swift concert, if she charges too much of the ticket, then not many people are going to buy because they can't afford it or that it's not that worth to them, stuff, so on and so forth. Okay, so um, you want to find the optimal, okay, optimal price here. Okay. All right, so we're going to get some quadratic, and you notice this is a sad parabola, so it's going to be negative. All right, so let's look for A. So for part A, we're just going to use the formula R of X is equal to X times P. Okay, so we need that X times P. So we know P already. P is this here, the price P. is -16x plus 60. So we're going to take that information and plug it in there. Okay. So we're going to have x times -16x plus 60. So that's going to give us -16x squared plus 60x. Okay. Again, I want it in this form where the leading term is the highest power. Okay. All right. So then this is my revenue R as a function of X. So that means the variables is in X. That's what I want. I only want in X terms. So this is part A. Okay. That's our revenue function as R as a function of X. Okay. All right. Now part B. So again, notice it's a minus here, right? So we have a SAT parabola. Okay, so now part B is asking what is the revenue if 60 units are sold? Okay, so basically we're going to plug in 66 in for X. So this would be R of 66 is equal to -16 and then 66 squared plus 60 times 66. Okay. So for the first part here, we should get -726. The second part here, we should get positive 3960. And then our result will be $3,234. So if we sold 66 units, okay, we would get $3,234. Okay. So in this case, if we were looking at our graph, this is from 0 to 360. So here's 0. So 360 is out here. And we're looking at 66. So 180, right, is in the middle. So 60 is in the middle. I'm sorry, 90 is in the middle here. So a little bit lower. So about right here, 66. All right, so this price point here. So this is your R of X, and this is your X, okay? All right, so it's saying if X is 66, all right, what's this value here? What's the profit or revenue? It's going to be $3,234. That's where that's coming in, okay? All right. Okay, hopefully that was helpful. So for this one, what it's asking us to do is to just identify the transformation that's happening. Okay. So for part A, right? So for part A, we have um a -3. So -3. So that negative, so um -3. So that negative there, right? The negative, okay. That's referring to it reflects over the x-axis. That's what that negative in the front is talking about. So again, we're just explaining the transformation. Okay. The 3 in the -3, okay, that is telling us it's stretching vertically, okay, by a factor of 3. All right. The -2 in the parentheses, that tells us that we're going to shift to the right by 2. Okay. All right. All right, so that's part A. Part B, same thing, right? So the 1/2, that's telling us that's going to compress vertically. The minus x here, that tells us it's going to reflect over the y-axis. And then the minus 4, which is the outside the parentheses, tells us it's going to go down by 4. Okay, so let me write that down. Move down by 4. Okay, and that's all she wrote for that one. Again, so we want to write this in standard form. So write it over here. We want to write this in standard form, which is a plus bi. Okay, so we want to write that in standard form, which is a plus bi. So how do we do that? So again, remember, we want to get rid of, so the goal is to eliminate the I in the denominator. Okay, that's our goal. We want to eliminate the I in the denominator. So in order to do that, we need to use, we need to multiply by the conjugate. Okay, so remember the conjugate is just saying it's using the difference of squares. So if I have, x minus 3, the conjugate would be x plus 3. Okay, if I have x minus 4, the conjugate would be x plus 4. Right? If I have x minus 5, then the conjugate would be x plus 5. It's just the opposite, all right, of the second number. So in this case, I have, again, I'm focusing on the denominator, okay? And so the conjugate would be 3 minus I. So if you didn't learn anything about complex number, you just multiply by the opposite there. So this would be 3 minus I, and then 3 minus I. Okay, we don't want this to be the same, and I get that a lot. Students will multiply by the same denominator, which is a no-no. Okay, and then I just do my scratch work. All right, so I have the 2 minus 3i times that by 3 minus I. Then we have the 3 plus I times that by 3 minus I. Okay, so to save us on time here, when we FOIL this out on the top, we're going to get 6 plus 9i plus 2i plus 3i squared. So that's going to give us 6 plus 11i. I squared is -1. So 3 times -1 will give us a -3. Give me a second here. Okay. Sorry about that. Oops. Okay, so 3i squared and I squared is -1. 3 times -1 is -3. So we get 6 minus 3, which is going to give us a 3. Okay. And okay. All right. Sorry about this. I was looking at something else. This should be negatives here. I apologize. This is to be negative and negative. So that's a minus 9i and a minus 2i. Okay. And that gives us a negative there. All right, so we get 6 minus 3, which gives us a 3 minus 11i. Okay. Okay, so that is for the top. All right. So top is 3 minus 11i. Now we need to work on the bottom. So 3 plus I times 3 minus I. So remember, that's just the difference of squares. Again, you can fold that out if you want to, but again, I'm just going to use the difference of squares. Remember, it's a squared minus b squared is a plus b, a minus b. So in this case, my a is 3. Okay, so that'll be 3 squared. And my b is the I, so that's going to be I squared. So that's going to give us 9 minus I squared is -1, so that's going to be a -1 here. So two negatives is going to give us a positive, so 9 plus 1 will give us a 10 there. Okay, so the denominator is 10. I can leave it in this form, or I can write it as 3/10 minus 11/10 I. It doesn't matter to me, okay? Either one is correct. Okay, so before you start applying the rule, okay, we have to get, so note, we have to get the absolute value by itself. In order to apply the rule, we have to get the absolute value by itself. I don't know how else to explain that. Okay, that means we can't have anything being added, subtracted, multiplied by this absolute value. We need to get rid of everything out. Get rid of everything out before we can apply the rule. Okay. All right, so in this case, again, I can't start going, oh, this is going to be -15 and +15. No, don't do that. Please don't do that. Okay, that is not correct. All right, we need to get the absolute value by itself. Okay, so that means then we need to add 5 on both sides. Give me pause it for a second. Okay, so again, we're going to add 5 to both sides. Okay, so the -5 plus 5 go away. And now we have 2 times the absolute value of x minus 3 equals 20. Okay, then we divide by 2. Okay, so now we got the absolute value by itself. This is what I mean. It's by itself. You have to get it by itself. So whatever it's adding, multiplying into it, being divided into it, get rid of all of that. We need to get this by itself. This is what I mean. Okay? Get that by itself. All right. So now we can apply the rule. Right? So remember, absolute value means it's how far away is it from 0. Okay? So if here is 0 in the middle, here's +10, then the other side will be -10. So it's 10, the distance from the right side is 10, and the distance from the left side is 10. Okay? So, so, um, so in that case, then we would split this into two equations. We would have x minus 3 equals -10, and then we would have x minus 3 equals +10. That's the rule, okay? We have to have two separate equations. But again, before I can split it, I have to get the absolute value by itself. If I don't, it doesn't work, okay? All right, so then we just solve. So add 3, add 3. So we get x is equal to -7. Add 3. So we get x is equal to 13. Okay. And those are our solutions there. Okay, so we want to solve this, right? That's the what they want us to do for this problem. So um, again, the first thing is we want to remember we're talking about exponential and log functions here. So first we need to get rid of this 6. So we're going to divide both sides by 6. Okay. So that gives us 2 raised to the x plus 3. And then 20 over 6, I can reduce that to 10 over 3. Okay. So remember the rule is if you have the same basis, then we can equal the powers to each other. Okay, if we have the same basis. So we try to, the bases are the 2 and the 10 thirds. Okay, those are the bases. So we're trying to equal them to each other, and that's not possible. There's no way I can rewrite 2 as 10 over 3 and vice versa. Okay, so that means if we can't solve it by exponential, we need to solve it by log. Okay, so we're going to write log, and then the base, remember this is little to the right equals middle. So the little in this case is 2. To the right is going to give us x plus 3, and in the middle is 10 over 3, right? Little to the right, 2 to the x plus 3 equals the middle, which is in the parentheses. All right, so if I rewrite that from log function to an exponential, that's what we would get, okay? All right, so now we can solve this. Okay, we went from the exponential function to a log function. And now we just subtract 3 on both sides. And then there's our answer. Okay. All right, but again, this problem is missed a lot. Again, so this one's g of x is equal to x cubed minus 12x, and we're trying to determine whether we have an even, odd, or neither. Okay, so determine whether it's even, odd, or neither, we had to plug in a negative x. Like if that's even, if it spits out the same, right? If you get the same result as the original, okay? If you get the same results as the original, then it's an even function, okay? If you get the opposite, right? If one was positive x and the other one's and the result was a negative x. If it's opposite, then you have an odd function. If you got it doesn't make any sense, that you don't get anything, then you get neither. Okay. All right. So again, the first thing we need to do here is we need to plug in negative x. So we have g of negative x equals negative x to the third minus 12 times negative x. Okay. All right. So that is the first thing we need to do. So it's number 10. All right, now after that, we need to simplify. So negative x to the third, that's just going to give me a negative 1 to the third, which is a negative still, right? Negative 1 to the third is negative 1 times negative 1 times negative 1, which is still a negative. Then we have x to the third, okay? And then we have negative 12 plus, sorry, negative 12 times negative x, which is going to give us a positive 12x, okay? All right. So let's look at this. We have x cubed minus 12x, and we have negative x cubed plus 12x. Is that neither? Well, let's see. If I were to factor out a negative 1, all right, so then we have then becomes x cubed minus 12x, right? This is a positive, all right? We have a positive here, and then we have a negative. All right, so these are opposite. All right, or this was a positive x cubed, you got a negative x cubed, you got a negative 12x, you got a positive 12x. It produces an opposite. So that means then, all right, or we have a negative in the front, all right, versus a positive in the front. So that means then this is an odd function because it's producing the opposite. All right, so we say this is an odd function. Okay, because it produces the opposite. Okay. Okay, so for this one, we want us to find the domain, range, and the asymptote of the given function. We have y is equal to log base 5 of x minus 1 plus 4. Okay, so let's first find the domain, right? So to find the domain, we look inside the parentheses, right? The x minus 1. That deals with the domain, okay? We take the x minus 1 and we set that to greater than 0. It cannot equal to 0 because, again, the log of 0 is undefined. You can put that in a calculator. So it has to be bigger than 0. Then we just add 1 to both sides. We get x is greater than 1. And that's it. That's our domain. The domain has to be x is greater than 1. What about our range? Well, the range is always going to be, in these types of problem, negative infinity to positive infinity. Because again, if we look at our log function, right? This is a log function. So the log function looks like this, okay? So the minus 1 says, hey, I move that to the right 1, right? The minus 1 says I move to the right 1. So right 1. And then the plus 4 says, hey, I go down my, okay, I go up a plus 4, okay? Right? The plus 4 says I need to go up the plus 4. So again, no matter how we moved it, shift it left and right, up and down, it doesn't matter. We're still going to get that same thing, even if it's being stretched. It's still going to be the same type of um, graph, okay? Or similar to it. So the range is still going to be from negative infinity to positive infinity, or all real numbers, okay? All right, and then the asymptote, right? That's just whatever value the x is getting bigger, x is greater than 1, it's always going to be this number, whatever number that equals to, okay? So this is going to be an asymptote at x is equal to 1. So if you had 2 there, you will put a 2 here. If there was a 3 there, you put a 3 there, right? Because it's shifted to the right one. So now, right, that's where that's where the graph is lining up against, is the x equals 1. So we have f of x is equal to, sorry, g of x. Okay, it's going to give me some issues now. G of x is equal to 5x over x squared minus 9. Let me pause it for a second. All right, so for this one, they want us to find the domain. Okay, and we have the function g of x is equal to 5x over x squared minus 9. Okay, so again, when we find a domain, remember this is called a rational function. Rational function. All right, and then in rational function, we focus on the denominator. Okay, so that means we take the denominator there and we set that equal to 0. We take the denominator out and we set it equal to 0 and solve. So we're going to get x squared equals 9. We need to add 9 to both sides, take the square root on both sides. We get x is equal to plus minus 3. So what does that mean? That means that all numbers are going to work except at x is equal to plus or minus 3. Okay? So the domain is all real numbers except at x is equal to plus or minus 3. And if you plug it in, right, if you put a plus 3 in there, you get 3 squared, which is 9, minus 9 is 0. And negative 3 squared, which is 9, minus 9 is equal to 0. All right, so that's the domain. All right, so That's our answer there. All right, so it's not going to work at those particular points. Okay, so this is a piecewise defined function. So that means that at certain parts, you can only use certain parts of the graph. Okay, so in this case here, for the first part, right, 5x minus 3, you can only use this part of the graph when it's between -5 and 3. All right, the second part of this is x squared minus 3. That means that graph is only graphed between 3 and 5. Okay, but not including 3. Okay, so that means that uh, these ones here, f of 0, 1, 3, and 5, just look at it. Let's just, you know, maybe this will help. So let's say I have a number line and draw a number line here. All right, so our particular points are -5 and 3. Okay, so and then we have +5 out here. Okay, so if if the numbers are between -5 and 3, including 3, then we use 5x minus 3. Okay? If the number is between 3 and 5, but not including 3, then we use the function x cubed minus 3. Okay? Hopefully the visual will help you. So 0, that's the first thing we're looking at is 0, f of 0. So if I go here, right, 0 is somewhere between -5 and 3, right? So I don't know, somewhere here, right? 0 is somewhere right there. Um, so in this case, then I use this formula. Okay. So for A, f of 0, that's going to be 5x minus 3, which is 5 of 0, minus 3, which is 5 minus 3, which is 2. So there's our answer for that one. Okay. F of 1, let's use a different color. 1 is between -5 and 3 again. So 1 is right here. So that means I use the same equation. So I'm going to use 5x minus 3 again. So that'll be 5 times 1 minus 3. So that's 5 minus 3, which is going to give us, oh shoot. Okay, 5 minus 3 is going to be 2. I messed up on that first one. 5 times 0, that's going to be 0. 0 minus 3 is -3. So let's redo that one there. Okay, so 5 times 0 is 0, and then minus 3 will give us -3. Okay. All right, and then 5 times 1 is 5. 5 minus 3 is 2. Perfect. All right, let's do the next one. Okay, 3. All right, well, we got, is it going to be the first one, 5x minus 3, or is it going to be the second one, x cubed minus 3? Well, we have to look. So this one says I'm including 3. This one says, no, we're not including 3 because it just says less than. This one says less than or equal to. So that means I have to use the top one again. Okay. So this will be, so there's 3, right? So I have to use that one. So again, 5x minus 3, 5 times 3 minus 3. So that's 15 minus 3, which gives us 12. All right, we got one more. Okay, so let's use orange. Okay, 5. 5 is out here, right? There's 5. So from 3 to 5, and 5 is included, so that means we use this one now. Okay, so that's x cubed minus 3. So 5 to the third minus 3. Okay, so that's 125 minus 3. So that's going to give us 122. Okay. So 125 minus 3, which is 122.